Let me take the curve here is parabola y square equal to 4ax. Okay, limits or the range is from 0 to h between x equal to 0 to x equal to h. To find what we have to find here, solution we have to find here the volume, to find the volume between the ellipse, the parabola x-axis and the ordinates x equal to 0 to x equal to h, and x equal to h. The ordinate, there are two ordinates here, x 0 to x equal to h. At 0 it is pole only, okay, the origin. That is the point here. So volume is given by, let me write, this is the same formula, pi into y square in this case into dx, limits here 0 to h. It will be written as, now y square equal to 4ax in terms of x. It is pi into 0 to h 4a into x into dx. It is nothing but 4 into pi into a into x is integrated as x square upon 2. Now limits 0 to h. This is 2 here, power 0 to h. It is nothing but 2 to the 4. So 2 pi into a into h square. This is h square here. Okay, this is the answer. 2 pi a h square. This is the volume. Okay, cubic unit. We can write the unit also, but no need of writing the units. This is the answer here. The volume of this parabola, okay, revolve around the axis of x with ordinates x equal to 0 to x equal to h, or between these two ordinates. Okay, so this is the volume here. Same answer. So this kind of answer we have obtained in the previous questions also. Okay, now this is question number 6. Now let me talk about question number 7. So what does question number 7 say? Let me now check it. Now question number 7. Okay, now it says find the volume of a hemisphere. Okay, now find the volume of a hemisphere. What is the hemisphere here? So if volume of a sphere is obtained by revolving a semicircle around the axis of x. Suppose this is axis of x, this is O to a, and this is minus a to 0. Between minus a to plus a, if I revolve this semicircle around the axis of x, this is x dash, this is y, and y dash x. This is semicircle here. So equation of the circle, let me take, which is x square plus y square equal to a square. Now this is the whole sphere, because this circle, if semicircle is revolved around the axis of x, a solid is obtained. That solid will be sphere. Now if I find out the volume of that sphere, now if I take the limit 0 to a only, then this a quarter of the circle of this whole circle, is to revolve around this. So this is the hemisphere here. So if I just write like this here, now this is the volume which we have to find out. This one, it will be this volume. If this is revolved around this, now in this case the limit 0 to a, this we have to write the limit 0 to a. That will be the volume of the hemisphere. Now let me first clarify this. This is to find, here we have to find the volume. Find the volume of a hemisphere. Volume of a hemisphere. It says find the volume of a hemisphere, okay, of a hemisphere, at the point. Now the volume of a sphere is obtained by revolving a semicircle. In this case, semicircle is this semicircle. Let me take this is A dash B and A dash B or A B A dash. Semicircle A B A dash around the x-axis, and between the ordinates x equal to minus a to x equal to plus a. This is the whole sphere. Okay, complete sphere is obtained. What is hemisphere then? This is the hemisphere, half portion. In this case, this arc AB is revolved around the x-axis. Now to obtain a hemisphere, a quarter of a circle or arc AB, or AB is revolved about or around the axis or around the axis of x, is revolved around the x-axis of x, and between the ordinates x equal to 0 to and x equal to a. In this case, x equal to 0 to x equal to a. If this quarter of the circle is revolved around axis of x, then this hemisphere will be obtained. That will be the volume. So only the limits are changed in this case. Therefore, volume will be volume of the hemisphere is equal to, here limits 0 to a, try to understand 0 to a, and this is pi into y square into dx. Now this is the equation of the circle. It will be 0 to a, pi into y square is a square minus x square into dx. Okay, so this is pi into d square, y square into dx, pi by square into dx. This is the value. Now let me solve it. This is pi into integration of a square is a square into x minus x square integration is x cube upon 3. Limits now 0 to a. Only a is to be substituted. This is pi into a cube minus a cube upon 3. Because at 0 lower limit, every term will be 0. Each term will be 0. This is only this value. This is nothing but 2 pi twice of a cube upon 3. That means 2 pi a cube upon 3. Undoubtedly, this is of hemisphere. Volume of the hemisphere is 2 by 3 pi a cube, which is half of the sphere. Half of the 4 by 3 pi a cube. Now 4 by 3 pi a cube is the volume of the sphere. Half of that is hemisphere. Hence it is 2 pi a cube upon 3. This is the answer here. 2 pi a cube upon 3 is the volume of the hemisphere. Okay. Now question number 7 we have completed. Now let me talk about what is question number 8 here. Now question number 8, let me talk about the question number 8 now. Question number 8 says, show that the volume of a sphere of radius r is this. Simple. Volume of a sphere we have to find out. So here again in this case, a semicircle, as I did tell you, is a revolve around. Okay, here radius is r. Okay, from this center 0, 0. This is x-axis here, x dash axis, and this is O. If this is a revolve around this x-axis, then a solid will be obtained, and that solid will be, this is a circle here, like this. This is y dash, this is y-axis, and here radius is r, so this is r. Now this semicircle, if it is revolved around the axis of x, then the sphere is obtained. Okay, here equation of the circle, this semicircle or x square plus y square equal to r square. Here r is the radius here. We know the equation of a circle is, this is general equation of circle which is passing through the center. Okay, I mean origin 0, 0 and having radius r. So this is r radius. Okay, so now let me take equation. So to find the volume of a sphere of radius r, this is the point. Let me find the solution. Now, if a semicircle x square plus y square, this is semicircle, here radius is r. Here limits we will take from 0 to r here, x equal to, this is r0 and 0 to a, because this is semicircle, but here we have taken the radius and limits from r minus r to plus r. This semicircle is revolved around this to obtain a hemisphere. This is r square. So not semicircle. If a semicircle, this equation of circle is revolved around the x-axis, okay, and between the ordinates x equal to minus r to x equal to plus r and x equal to plus r, minus r to plus r, if this semicircle is revolved around, then we can get the solid. That solid will be a sphere. That volume we have to find out. Therefore, the volume of the sphere thus obtained, the volume of the sphere thus obtained, or thus generated, thus obtained, is equal to limits minus r to plus r, try to understand, into pi into y square into dx. This is around the axis of x. Okay, this is, let me, minus r to plus r, this is limits. So whenever limits are minus a to plus a, we write it twice 0 to a. This is definite integral property, 0 to r. Now this is pi into y square is, from this equation of the sphere, r square minus x square into dx. Now we have to convert this into variable x so that we can integrate with respect to x. So y square is changed into r square minus x square from this equation of the circle, the first equation. Now this is to be integrated. This will be twice pi, integration will be r square into x minus x cube upon 3, limits now 0 to r, because radius is r here. Okay, so now let me write it here. Therefore, the volume in this case will be 2 pi into r square into r, which is r cube here, minus r cube, the upper limit we have substituted, which is r. In place of x, we substitute r square into r is r cube, minus r cube, because r whole x whole cube is r cube upon 3. Let me solve it. It is 2 pi into 2 r cube upon 3. It is nothing but 4 pi r cube upon 3 is the volume of a sphere. 4 by 3 pi r cube, volume of a sphere. Hence, this is the volume Okay, is cubic unit. Unit of this is cubic unit. This is the volume of a sphere. Answer. This is the answer here. The volume of a sphere is 4 by 3 pi r cube. That's the volume of the sphere. Okay, so we have obtained this question number 8 also. Let me now talk about question number 9. What does it say? Okay. Now let us talk about question number 9. Find the volume of the right circular cone of height h and a base of radius a. All right. So in this case, what is the equation here? So find the volume of a right circular cone of height h. Okay. Now here it is a cone we draw like this. So this is the cone. What we have done, this curve is, now this is the cone we have obtained. Let me write this up to this point. This is the cone we have obtained. Now this point, the radius of this cone is a here. This is a, so y equal to a here. Y coordinate about this is a point here. A point is x and y, so this is a and this is h. Height is h here up to this point. So height of the, okay, sorry, this is 6th, 5th one. And 8th question is, sorry, 9th. Find the volume of the right circular cone of a height h, alright, and angle, let me take here alpha. This is vertical, semi-vertical angle alpha. Okay. Now if I find out h is what, a is what, then what is the volume of this? This arc is revolved around the axis of x. This is the axis of x, O, y, and y dash axis, x dash axis. Okay, so this point, let me take O, A, this is B point here, center of this, and this is C point. So now in this case, this arc is revolved around this axis from this 0 to this point. Limit should be 0 to this point h. Height is h here. 0 to h we will take because here it is h and 0 base point. So what is value of h? Let us talk about. Okay, in terms of alpha angle. And what is a point here? This a we will just calculate. We substitute then. So in this case the volume will be, okay, so that is the point. This question when I find the volume of the right circular cone of height h, alright, and the base of radius a. This we have to revolve around the axis of x. So this is the cone which we have obtained. It means we have to find the limits from this minus a to plus a, and here it is, this area is a and this is minus a. Let me take the, here it is minus a to 0, or now in this case this is y coordinate, so we are not to take. X coordinate is here minus a, and y will be obtained in terms of h here. Sorry, this a is the radius here, a is the y coordinate, sorry, h is this value. So this is h here, x coordinate, and this is minus a. Minus a, this is h and plus a, no problem. So these coordinates are there. Now in this case, the volume of this solid will be obtained by revolving this. Change the marker here. Marker have to change. Okay. So now in this case we have changed marker. The question is volume of the cylinder. We have to, sorry, this cone we have to obtain here. Okay. Volume of the cone is, in this case we have to obtain, that means x square into y square into dx we have to obtain. So the y square, that means let me take p point, any p point here. If I take an elementary strip here, sorry, this is the elementary strip. If I take the p point, this is p point, p coordinates are x and y. Okay, so in terms of, we know that what is the volume? Volume is obtained by, now sorry, this is question number 9, so let me write here. Curve given here, nothing. Curve is what is that? Cone to be obtained by revolving the arc OA around the x-axis, OX axis, let me take, around OX or x-axis, around OX axis or OX line. Okay, this solution we are calculating. Now we know that what is the value of this. So we know that volume is pi into y square into dx. This is the volume of any sphere. Now from 0 to x here we have to take, it is 0 to x here, limits we have to take, but we have to take 0 to h. So here initially we are taking x here, let me take h, because limits are 0 to h. 0 to h here. Try to understand. 0 to h. Okay, now let us talk about what is y square here. Now y is this coordinate. So y upon this x, tan alpha is angle alpha we have taken, tan alpha equal to x upon, sorry, this is y upon x coordinate. Okay, now y upon x or tan alpha is this value. So y is equal to x into tan alpha. Y equal to x into tan alpha. Y equal to x into tan alpha, where tan alpha is equal to a upon h. Tan alpha equal to, where tan alpha is equal to, basically tan alpha equal to a upon h. A is the base, in this case this is a upon h here. We will substitute here x as a upon h finally, but x is this value. So y square equal to this. Tan square means a square upon x square. We will substitute. So tan square alpha is constant, but finally we will substitute the value of that. So this is pi into 0 to h, let me take, and this is x square into tan square alpha into dx. Now tan square alpha can be taken outside. The tan square alpha I have taken outside, and this is x square only, so this is x cube upon 3. Integration of x square is x cube upon 3. 0 to h here. Okay, now tan alpha is a upon h. Tan square alpha will be therefore a square upon h square from the triangle OAB. We have taken tan alpha equal to a upon h. From this smaller triangle we have taken tan alpha equal to this y coordinate of b divided by x coordinate of b, that was y upon x. But so just we have generalized this value y equal to x tan alpha, but tan alpha basically is this point from this triangle in terms of a and h which are given to us. Okay, so this is a square from h square, tan square alpha value, x q is h q upon 3, with nothing but 1 upon 3. Now 1 h square or h cancelled out, so this is nothing but 1 upon 3 pi into a square into h. This is volume of a cone, 1/3 of the volume of a cylinder, pi r square h. R is the base of the radius of the base. This is 1.3 pi into a square h. This is the volume of the cubic unit. This we know about the volume of a cone. Let me take the sphere here, sorry, cylinder here. Why this is 1/3 of the cylinder, that we know about. Now this is the cone. Let me take this is the cone here. Half part is this, 1/3 part is this, first part, second part, third part. This is cylinder here. So 1/3 part of the cylinder. Volume of the cylinder is pi r square h, or pi a square into h. area of the base into height. Height is here h. This is h here. Area of a cylinder is area of the base into height h. Pi a square into h. Pi r square area of the, suppose this radius is r of the cylinder. Okay, base radius is r. R square, pi r square, area of the base. Base is cylinder, sorry, circle. The area of the base of a cylinder is circle. Area of the circle is pi r square into height h. That is the volume of the cylinder. Then 1/3 of that is volume of the cone. This is 1/3 part. Cone is a 1/3 part of a cylinder. This is the volume of a cylinder. Sorry, volume of a cone here. And the answer. This much cubic unit 1.3 pi a square into h, where a is the radius of the base, height is the h. That is given to us. Find the volume of a right circular cone of height h and base of radius a. Simple. This is the answer here, 1.3 pi a square h. Okay, so finally this question is 9th question we have completed. Now let me take question number 10. What does question number 10 say? Let me check. Now question number 10 is of what kind? Let me check it. Okay, now question number 10. Let me do this. Clean it. Let me clean it in a proper manner. To darken. Okay, now question number 10. Let me talk about. What does question number 10 say? That we have to now do onwards. Okay, so now question number 10, it says that find the volume of the solid generated by revolving the ellipse about the x-axis. Okay, ellipse x square upon a square by square upon b square is equal to 1 about the x-axis. Simple. Let us take this question number 10 here. Here ellipse. This is the ellipse which we have described a number of times. X-axis, this is O, y-axis, origin O, this is x-axis. Now here we have taken the ellipse. The curve here is the ellipse. Curve is the ellipse. What's the equation of the ellipse here? This is x square upon a square plus y square upon b square equal to 1. Question number 10. Find the volume of the solid generated by revolving the ellipse about the axis of x. Okay. Now this ellipse, if it revolves around the axis of x, then a solid will be obtained, and that volume we have to find out. So the volume of that, let me find it. That means the major axis is A here. This is A0 point. This is minus A0, and this is 0B, and this is 0 and minus B. So this minus A to plus A, this ellipse is revolve around axis of x, and this is from minus A to plus A. If I take this semi ellipse, I mean, okay, semi ellipse, and then that will be obtained. So answer finally, volume of the, let me write here, volume of the solid revolved around, solid obtained by revolving, solid obtained by revolving or revolved around the axis of x, in this case the ellipse is revolved around, ellipse is revolved around x-axis, simple point. That means again volume will be, we know that this is pi into y square into dx, because this is axis of x. Now here minus a to plus a is the limits. Minus a to plus a, because ellipse is revolved around the axis of x. What is around the y-axis? then minus b to plus b limits will be, so there is a half portion. Okay, now let me change this. This is twice pi. Let me take outside twice y because this is 0 to a now limits. This is definite integral property that when minus a to plus a limits are there, then we can change the limit 0 to a and twice we have to multiply by 2. So this is twice pi. Y square is replaced by, from this equation, this is b square upon a square into a square minus x square into dx. This is from equation of the ellipse, because y square upon b square equal to 1 minus x square upon a square we obtained. So y square equal to b square upon a square. We have taken a square LCM, which will be a square minus x square. This value from the equation of the ellipse we have substituted here. This is by b square upon a square into a square minus x square dx. This will be twice pi. Let me integrate. This is b square upon a square outside. This is a square into x minus x cube upon 3, 0 to a here. It is nothing but twice pi into b square upon a square into this is twice a cube. So this is a cube. Twice a cube upon 3. Twice a cube upon 3. It will be finally 4 pi. Now it is b square and a square one cancelled out by a cube, so only a will be left. It will be 4 by 3 pi into a into b square. This is the volume of the solid obtained by revolving the ellipse around the axis of x. So finally answer is this. Now let me write the answer here. So this volume of this ellipse is 4 by 3 pi into a into b square. This is the answer of volume of the solid obtained by revolving the ellipse around the axis of x. This is cubic unit. We can write cubic unit, no need of unit, but this is the final answer. So answer of question number 10 we have done. Now question number 11 also let me take. What is question number 11 say? Let me check it. Okay, so now question number 11. What did you say? The